Hello everyone, and welcome to a new episode of Inference, where we talk about programming languages and other funny stuff. Today, I am really happy to have here an incredible developer from Italy for the first time, Luca Piccinelli, and today we will be talking about COBOL. Welcome, Luca. How are you?
I'm fine, thank you. Thank you, Michele, for having me here in your interesting podcast.
My pleasure. I would like to ask you, what are you doing today if you are still working on COBOL, and why did you get started working on COBOL in the past?
Okay, so actually, no, today I'm not still working in COBOL every day. I was working in COBOL partially up to 2 years ago, about, and then since about 2 years that I'm working backend side in Kotlin. And a little different from common and also different
Yeah, absolutely.
different period of time. And I started working in COBOL in 2010 when I was 25. Actually, not because that was something that I liked to, but actually just because it's something that I needed to. Because previously I was working in Milan. I was working in Java, on Spring. I was working on a social network inside a famous Italian company and a very big Italian company. But
Okay.
I liked what I was doing, but I didn't like to live in Milan because the city life is not for me. City life, sorry. And I wanted to come back to my valley, that is Valle Camonica,
Wow, an
and
amazing place. Yeah,
amazing place, yes, indeed.
yeah.
And I searched for a work and I found this local company that was working in COBOL, and so I accepted to work it there because I wanted to come back to my home, actually, and that's
Okay.
the main reason. But looking back, I'm happy of the choice that I did.
You told me that you had a previous programming experience before
Mhm.
going working in COBOL. So I guess it has been shocking for you to starting working on COBOL after maybe working with more modern programming languages in the past.
Yeah, it was. Indeed, it was. It's shocking is the right word because you're used to have something that makes your life easier every day. Like you study certain data structures at the university, like or also data types like integer, float, byte, or whatever, and then you expect to having that types in all of the languages that you go, because maybe you are used to have I don't know, C or Python or Java or PHP, and actually you always find out that types or and also some data
Yeah.
structures like dynamic arrays, like trees, linked list, and whatever. Then you step back to COBOL, you step to COBOL, and you don't find anything of this because the data types are different.
Okay.
Our dynamic arrays or data structures are not implemented by default or actually at least they was not implemented in the runtime that we were using, because in COBOL you have many dialects and all the dialects are very different one from each other in their implementations. It's different, and also you're used maybe to have your memory allocation for functions. You have the stack, you have the heap, and you are used that when you have the scope of functions, so that if you call a function, you expect that the variables that you allocate inside the function are scoped into that function. In COBOL, is not in that way. So there are many, many differences, so it is actually shocking, yes.
Okay. And talking more about dynamic arrays, before recording this interview, you actually told me that you've implemented a library for giving support for dynamic arrays in COBOL. How did you do that?
Well, I did because I needed it. I needed a library for handle dynamic arrays, and as I said, it was not implemented in the SDK that were used or in the runtime. And coming from an experience of different language, that was something that I was expecting to have. So at the beginning, I didn't use it, but it's not easy not having that kind of data structure in your day-by-day work. So in the end, I decided to implement it. And how I did it because also in COBOL you can access to dynamic memory allocation because there are facilities
Okay.
to call the APIs of the operative system. And also there are also some function provided by the runtime that invokes that APIs. So there is a memory allocation function, and with that I built up the library. And there are some things that are not so easy, also if you have a dynamic memory allocation, but one by one were addressed in some way. And
Okay, so it's
okay,
really low level programming at this point, right?
yeah, yeah. It's low level. It's quite low level programming, and it's interesting because it's not something that you do every day. At least you don't see every day going
Yeah,
production that low level. Something at
yeah,
that.
absolutely.
Mm,
And you also told me that you're developed that let's call this extension library. I don't know how to call that, but let's call it library for dynamic
mm.
arrays using TDD, which is an extraordinary modern methodology. Let's call it that way.
Yeah.
And how did you manage to work in test-driven development with COBOL?
Okay, for this maybe I have to put a distinction because the one that I developed using TDD is a second version of that library because the
Oh,
first version
okay.
that is the library is actually in production is proprietary of my company. And also, I was not so good in test-driven development the first time that I developed that library because we have to go back to 2011 for the first version of this library. But just few years ago, maybe 1 year and a half ago, I decided to rewrite from scratch that library and make it an open source project. So I decided to try to do it with the TDD, test driven development, because now today is the my natural way to develop something. In COBOL, it's not so simple because you don't have the testing frameworks. Yeah, so you have to.
Oh, okay.
So yeah, I also wrote some simple assertions, but very simple assertion that also are works when the things works when everything is okay. You can see okay, this test has passed with his description. When something fails, okay, it just says okay, it fails. In some way tries to give you the point of failures, but not always works. But for me, it was enough to go forward with the approach. And also in this specific case, there is it's more easy to address this approach because it's all about computation. So I don't have any I/O, and that complicates the use of that technique. Also, the specific task was more easy and was fitting the technique. So I also developed some assertions. And if you want, we can also have some example. There is the repository that is on my GitHub.
Would you like to share some code on screen?
Yeah. Okay. So we can close the left part so that we can focus on a quite usual structure of a test project. So uh, each of these call are the test cases, and inside of each test cases, you can find your assertion. So, for example, here, this is the program that I'm calling to perform the assertion. So it's called assert. I'm asking to verify the equality of this that I am allocating the array, and I am expecting that the array is going to be actually allocated. And so
Okay, okay,
then if you run it, you can see
okay.
a
Test is
console
okay.
output that is okay about all the test cases. Obviously, if something is going to break, you can see KO, and in the end, there are 22 were executed, and so the report summary of the execution.
Okay, it was pretty fast actually. I don't really know how to how to measure performances of COBOL. Do you think that it's a performant programming language actually, or compared to other languages?
It's a difficult question in this case because probably it depends from the dialect, because for example the dialect that I'm using, that is Aku COBOL, is is interpreted, is not
Oh,
compiled, so
okay,
is compiling to middle artifacts that can be like Java, so that you compile in bytecode and then you give that bytecode to the Java virtual machine. For me,
okay,
it's about the same. So I have this crun 32.exe that is taking this test array.aku. That is my artifact. That is the compiler artifact from this test array.cbl. That is the source code. And so it's pretty much like I don't really know the internals of this, but the external structure is very similar to a virtual machine. What I can say, if we go in the sort algorithm, in the sorting algorithm of my library that is implemented in QuickSort,
oh, okay,
if you compare with the C sorting algorithm of or C++ or also to the Java sorting algorithm, we speak about order of magnitude worse than the Java version. But
oh, okay,
so is very slower compared to the Java version. But sincerely, I don't know if it's slower because I did something wrong in the implementation, or so there is a way to make it run faster. I tried to squeeze everything at the maximum that I was able to make it performant, but it was not actually really comparable to the other languages.
okay,
It's in order of magnitude slower. And this is the specific case. Then if we go about, let's say, if you go, if you are able to reuse algorithms implemented in the runtime instead, then what I can say is that is faster, is really fast. I don't have benchmarks, but every time that I wanted to go fast in something, I tried to reuse at maximum of what I could do at the maximum the runtime, so the already implemented function given from the
okay.
runtime. In that case, it was really performant. For example, we can see this complicated statement here, declaration here, that is a way to use the arrays that I implemented, but passing through the facilities given from the language. So it's not easy to to explain this if uh, and if the language is not known, because is, as I said, is different. This is this linked section and this usage of this structure is very similar to having a pointer in C. And this is
Okay.
similar to dereferencing a pointer. So with this, I'm going to dereference the dynamic array using a syntax that is typical of a static array of the COBOL. Instead, COBOL gives you static arrays, and the name that COBOL uses to have static arrays is tables. So
Okay.
this is the syntax to have a static table, but I am using a mechanism similar to, actually, I'm using pointers, but I am in some way dereferencing the memory allocated with a dynamic memory allocation that is actually a malloc like C. So I perform a malloc, I allocate a contiguous block of memory, and with this linked section, I can put a pointer over that memory and then access that memory like it was a static table of COBOL. This is a way to access the array. There is another way that is more intuitive but less performant. As I said, every time that I want performance, I try to use the things that the runtime gives me and not something that I build over
Yeah, makes
the
sense.
runtime. And in this case, for example, you have, for example, binary search already implemented from the runtime, and you can use that binary search. I also implemented binary search in my library, but they are totally at a different scale of performance. Why I have both? Because one is simpler to use, the other is more performant. So I have to choose given the task that I am doing.
Yeah, absolutely.
I don't know actually about the other dialects. I know that there exist dialects that compiles natively. Maybe also the open source COBOL, the new COBOL, I think that is compiling natively. And I don't know sincerely about the performance of that language.
You previously told me that you've implemented QuickSort in
Mhm.
COBOL. I would love to see a QuickSort implementation in COBOL if you
No,
can share.
you don't trust me. Okay, but we can go there.
Yeah.
It's not the recursive version because
Okay.
having recursion in COBOL is not as usual. Is not like you would expect. It's something a little different. Also, every time I have to speak about this dialect that I remember is Aku COBOL, but recursion is tricky in COBOL.
Why is it so tricky?
Okay, it's tricky because the way that you call, previously I said that you don't have a scoped function. So scoped function,
Okay.
I mean with their allocation of scope allocation. It's not totally true. You have them, but they are not function. They are programs. So you can call another program. For example, that's actually the way that I'm implementing a library. A library is actually another program. So these perform, for example, are procedure, internal procedure of a program. You can call this in this way. So perform this procedure from here to here. There is also the syntax that you can do directly only with perform escaping the true. It's only a syntax. We are used to do at my company. We are used to do in this way. And so in this way, for example, I'm going to call this piece. These procedures are not scoped, so every variables that I'm using here are declared in the scope of the program where the procedure is declared. So, for example, this expected array type is declared, no, it's outside, but in COBOL, I have this section that is called working storage section. There is the place where I allocate variables on the stack. so not on the heap of the dynamic memory, but on the stack. These are scoped,
Okay.
so these exist only inside this program. But when I call this test allocation, that is a procedure, then I can use the variables of the working storage section of this program. The variables inside here are not scoped to this procedure, are global
Okay, got it.
to the program. But what can I do? I can call another program. Okay, for example, here I'm calling this array new. That is this is not really another, is an entry point of another program, but let's stay, don't complicate it too much. It's another program. In this case, everything that is inside this is scoped to that program. What is the problem?
Okay.
What is the problem? The problem is that calling another program is very expensive in terms of performance. Why? Because the first time a program, when you compile a COBOL program, you don't compile things and link things together like in C. They are dynamic, so you compile only that program. If you want to call another program that is compiled by itself, you have to call it and find it in the same path, or or you have to point in some way the path where you have to search for the other programs. But that program is fetched at runtime, so it's going to bring it up at runtime from the disk the first time. Then the next time, until you don't call another instruction that is used to unload the program, the other time is cached. But the first time is fetched from the disk, so it's very, very expensive. And also, when it's cached in memory, is not as performant as calling another procedure. So, stepping back to the reason why recursion is tricky, that's why you don't have recursion on procedures. It's not possible to have it. Actually, you can call a procedure inside self, but it's not a real recursion. It's that just like a goto. So it's just going to back to
Okay,
the
okay.
okay. So it's like a goto. It's not a real recursion. You can have recursion on the programs, these programs. In this dialect, in the implementation of this dialect, also that is not a real recursion because is allocating every time that you call it, is allocating another. You can have two options. You can decide to allocate it another instance of the same program in the recursion tree, or you can choose to go again inside the same instance. So it's similar to a recursion, but it's not a recursion. Anyway, if we are implementing an algorithm like a QuickSort that should be quick, calling something is out of your options because
Okay.
otherwise, as I said, is already slow. If you call something out, it's going to be much more slower. That's why actually is not implemented with recursion, but with the no, with the algorithm, the procedural algorithm.
So, can you share the code? It's
Talk is
really
cheap.
interesting.
Show
Yeah,
me the
Turkish,
code.
show me the code. Great.
Show me the code. Okay, with the code, it's not, as I said, probably it's not as longer as you probably are going to expect it to be longer
Okay,
because
great.
only this part is for receiving parameters for the other call, only this line. And this is a macro that is squeezing about other 10 lines inside it. And also this
Okay.
copy are other many lines. So probably if I'm going to explode this, are going to be about 50 or 60 lines only to receiving the
Wow.
parameters. Okay.
Okay.
And there is a reason also here is not the only way, is a way to decouple the caller the structure that the data structure that the caller is using from the data structure that the receiver is using. It's a technique. It's not mandatory. And then, then I have many internal procedures. Okay, in this case is actually quite short. This return is the only time that I use a goto, because this return is a
Okay.
macro, but inside is a goto. Is a goto to
Okay. Let me sorry, I'm seeing on line 221. I see compute pivot, so you're taking the pivot for performing the partition, I
hmm
guess, at this
hmm
point.
Yep.
Then perform partition, then
hmm
push left partition. Okay, so you're basically sorting the items inside the array. And I don't see, I see perform partition, and I do expect partition to be a function or a program in that case.
hmm
How do you pass variables to that Q partition
Mm, they
program
are
function, whatever it
they
is?
are global. They are global
Oh,
because
okay.
actually not really global, because we are sorting an array, so we are referring to the memory allocated and referenced from this data structure. This data structure is the data structure that of an array that is something like maybe I can show it. How is an internal structure of array? I have the pointer. I have the pointer.
Okay.
Is actually this is quite similar to how you would expect an array. It is okay pointer, but then from my experience, I added this array version that I didn't added in the in the first version of the library. So, okay, here I added it. And then I have the part of data. So how big is going to be every element of the array, how long is going to be the array, and then the private attributes that are going to be capacity. And also here I have a type that is an indication about the fact that it's going to be numerical or alphanumerical, and
Okay.
is useful for other tasks. And then this filler, okay, I think that we can skip this, but COBOL. I know that COBOL addicted will recognize this keyword. It's actually
Okay.
something that say reserve some memory for future use, something similar.
Okay.
Okay.
May I ask you a probably stupid question?
hmm
And maybe I can also answer myself. But if you're running a quicksort using global variables only, how do you handle race conditions? I mean, those variables may be scoped inside the scope of the program, so you don't actually have any race condition because every time you call a quicksort, you actually are running a different program. But uh,
Not really,
okay,
not really. Mm.
okay,
No,
could you
no,
please
no.
explain this?
Okay. I avoid the race condition probably because in the environment that we distribute to this program, probably we don't actually have so many frequent race conditions, because
Oh, okay.
is something that is not inside the blood of our environment, because it's actually we distribute we have about 10 more than 13,000 customers, so more than
Wow.
that means more than 13,000 installations in all the Italy. So everyone
Okay.
has, because it's a desktop application. They use there is a concurrent access of some resources, but I don't think that there are actually if you always use the same instance, but in different machines. So they actually
Okay.
are different instances. But anyway, why also you don't have race conditions? Because This is not global. This is allocated in the external program. So the program that is going to call this array sort is passing you the memory that is from that program.
Oh,
It is a
okay.
specific array. Then actually probably somewhere here I'm going to allocate, okay, I am this free pivot value. So I'm also allocating dynamically um, something here. And yes, probably here I would have a race condition if I was in an environment with that problem. Because I'm not sure about that. Probably I never analyzed that because we don't really never needed to use in that way
Okay, okay.
in our environment. I don't really know if that could be a problem. Actually, because
Yeah, no,
if you call it another
yeah,
time, then you are going to allocate in another memory because you're going to call two times this m alloc. This is the m3, but there is also m alloc. But we are always using the same
pointer.
variable, the same
Oh,
pointer. So probably
okay.
yes, this is going to overwrite another in a concurrent call. Yeah, probably.
Okay.
Mm.
If there's anyone looking this episode, they will know that I've always talked with people coming from the functional programming world, where it's really, let's say that it's a bit harder for functional languages to have race conditions because of pure functions and stuff like that. So, most of the times it becomes, easy for me to reason about concurrent programs. And when I
Mhm.
see this stuff, I always ask myself, okay, where can I spot a race condition? I don't know why, but
So,
it always came in mind.
okay, I can understand. Yes, yes, for sure. If you are in web development or cloud environment, or yes, that in that case is going to be a problem. In my case, probably was never been a problem, but I think that if it was, there is a way actually, I'm not sure that is going to be a problem, but if it is, there is also a way to escape that problem because you can ask to call different instances of that library every time.
Okay,
There are ways to do it. At least
okay,
it seems to me to remember that there exists a way to do it. Also recursion. Sometimes I use the recursion. Now I sometimes I use the recursion as a workaround to instantiate different instances of the same program. Yes, it's something that I did many years ago.
okay. This is really interesting. Not only because it's COBOL, but also because I feel like this is very low level programming, and you have to be an expert on how computer works to make it work properly.
Mhm.
Am I? I don't know if that is true, but I really feel like this requires some expertise.
It requires some expertise, maybe sometimes not actually how the computer works, or well, yes, also. But some other times you have to squeeze your environment, your runtime to, as I said, you don't have so much already implemented in the runtime. So everything that is already implemented, you have to take benefit and advantages from that. For example, I also implemented the decoding of base 64, decoded
Wow.
and encoding of base 64. And in that specific case, if I used for the alphabet, the 64 characters that used for encoding or decoding, if I used a static array or a static table, that is the normal way to use in COBOL to allocate an array, in that case, using that table to reference the alphabet was very slow. And I found a way to make it go faster changing the collating sequence of the program. So I used some function that are built in the runtime, and I said to that function, your alphabet is not the standard ASCII, but now your alphabet is these 64
Okay.
characters.
Okay.
In that way, using that as a table or array in order to to find the index of a specific character, it worked much more faster, the decoding and then the encoding process.
Got it.
So maybe sometimes you have to know the runtime that you are using.
Okay, so going on into the conclusion for this episode, I feel like writing COBOL in 2021 can be challenging sometimes, but it's really rewarding. I feel like you are discovering so much about how computer works, how to squeeze the language and make it work how you want. Uh, do you think that it is worth to learn COBOL in
Mm,
2021?
Actually, learning COBOL, I don't really know if it's something that is worth because you get back this kind of thing that you said. So going deep on the things, if there are two conditions. One, the team that you work with let you actually play with the runtime and give you the time to do it, is interesting in doing find a new way to do things. This is the first condition. And the second condition is that you have the chance to go in production because you need to go so deep only when you have a production and usually not when you are playing with a language. So
Okay, yeah.
is probably I wouldn't invest in studying in that language if I don't have already in mind a specific goal. So I want to have a career in legacy code refactoring. So my topic is going to for all my life is going to be legacy code refactoring. So I'm going to learn legacy code. I'm going to learn technique to address legacy code and so on. But in the other ways, no, probably for a junior is something that I don't suggest.
Okay.
Just to learn something new. If you have to learn something new, probably to be appealing for the market, probably you should choose something more modern because it's going to be more marketable. Only
Yeah,
because you are
sure.
more appealing. But yes, if you want, if you are curious, why not? If you are curious and you like it, okay, then it's another story. And yes, you have the opportunity to learn so much about how things works.
Yeah, absolutely. Okay, so last question. How do you see the future of COBOL? Because we know that there are some, code bases that are so huge that it is impossible to refactor those code bases to Java or any other language because they are so big and we
Mhm.
just can't do that. So how do you think that the future of COBOL will be in the next 10 years, 20
Mm.
years?
As you said, I don't believe about the Big Bang rewriting of a project. Also because some are really mission critical. So if you it's enough a little error to break everything. Also, I don't really trust fully solution that now exists that take your code and compiles it on another platform,
Yeah,
let's say over .NET platform. I don't really trust it because you are only taking a code, but the behavior, the implementation is totally different. So probably something is going to change, and you is not easy to find. So how I see the future, I hope that the maintainers of the COBOL runtimes continues to maintain it. So continue to have the
yeah.
business reason to maintain it, at least the biggest one, let's say Microfocus, IBM, or whatever. And what I see they should find a way to take that code and put in some way in a more modern context. So maybe I see better something like techniques like using the golden master technique to address, to tackle your legacy code base, structure it, take out maybe the core business logic in some way, take that business logic, use it as like a black box, and call it from another more modern environment. I see something like this more real for the future, but
Yeah,
it's
makes
very
sense.
difficult to actually have a prevision of that.
Okay, great. That makes sense. So, thank you again for being my guest for this episode. Time flew. I really appreciate the fact that you shared the code. You are actually the first person in this podcast sharing some code, and I really like that. So maybe in the future I will ask more my guests to share their code because it's really, really interesting. I'm sorry for people listening to us on Spotify, but this is an episode that you have to see on YouTube. So, sorry again, but thank you, Luca, for being here. Hope to see you again in a future episode, maybe where we can talk about Kotlin, because I know
Yeah,
that you are really well focused on Kotlin.
yeah,
And
I
yeah,
like it very much. Yes, thank you, Michele. Thank you to you. I hope that what I explained is clear enough to the audience, but I hope
yeah,
at least if
absolutely.
something is not clear, you can get in touch with me on LinkedIn or Twitter or where you want. And
I leave some contact information in the description field for this video, so if you want to get in touch with Luca, you can find all the contacts in the description field. So thank you again, and see you next time.
thank you, Michele. See you.